Okay, hello there, everybody. Here comes your. Ooh, I gotta close those. Okay, there we go. Sorry about that. Boop. Find the missing side length or edge length of the cubes and squares and cubes below. Round to the nearest thousandth necessary and write the exact reduced roots if you can. Alrighty, you're gonna want to pause the video because we're ready to go here. Okay, everybody, let's get this show on the road in 5, 4, 3, 2, 1. Let's see here. Okay. All right. Will you guys go ahead and let's see if I can get some help here. Alex, what kind of root did you use to find out what the side length is for the square on number 1? What kind of root did you use? Like what was in the index? Oh, that works too. Yeah. And if there's nothing, what is there a secret? There's a secret something there, Alex. What is it? There's a secret 2, because it's what number if I multiply 2 of them gives me 50. And if you actually ask your calculator that, it'll give it to you exactly. The square root of 50. That's 5 square roots of 2. Okay. And so we can say that the exact side length is 5 square roots of 2 kilometers. And then to get the approximate, you can just jam that button right there. And we're going to round to the nearest thousandth because that's what the ACTs do. 7.071. 7.071. So it's about 7.071. How many of us were either able to get that or see how we got that and aren't too alarmed? Beautiful. You'll love to see it. Okay, let's see here. On a go. What about on number 2? What kind of a root did you use on number 2? The third root. Very good. So the third root of 54. What number if I multiply 3 of them gives me 54? Come on, nice number. Come on, nice number. 54. Hey, hey, hey. Nope. 3.7797. Ooh, people hate rounding that to the nearest thousandth because after the 9 comes a 7, which means we need to round a 9 up to a 10, and that turns that 7 who's next door into an 8. 3.78. So it's about 3.78. Now, if you ask your calculator, will you please give that to me exactly? Your calculator says no. And you're like, pretty please? And it still says no. So we have to reduce this manually. And we're going to do it like this. We're going to break up 54 into its factors, into its prime factors. What numbers of what numbers go into 54, guys? What can I multiply? 9 and 6. Is that what I heard? And then what's 9? 3 and 3, and 6 is 2 and 3. So I'm going to go ahead and change this into the third root of 2 times 3 times 3 times 3. I'm looking for a triplet. Do you guys see any triplets of numbers? Threes. So we could, in fact, put your pencils down if you're following along with this. I'm going to show you the long way, and then I'm going to show you the shortcut. You could think of that as the third root of 2 times the third root of 3 times 3 times 3, which is 27. But the third root of 27 is not surprisingly 3. Because this is saying what number multiplied 3 times is 3 multiplied 3 times. What number would that be? 3. So there's actually another thing you can do. And got a pencil? If you see a triplet of numbers in there, you can actually just circle them, cross them out, and bring the numbers you crossed out to the beginning. That's because I've got a triplet of 3s, and I know that what number multiplied 3 times is 3? To 3 multiplied 3 times, it's 3. And so I can actually pull them out that way. And that gives me 3 cube roots of 2. That would be the exact. Was that a question, Essie? Please. If it was... So you're saying, put your pencils down. Let's see here. You're asking me about what if I had like the third root of 4 times 4 times 4? Like that? It can be 4s, yeah. So if it was like 4 times 4 times 4 times 5, I could still find a triplet of 4s, pull them out, and then do 4 third roots of 5. So it doesn't really matter that these are 3s. What matters is I have 3 of them. Very good question. Very good question. Sina. So it's kind of weird. So it's really hard to illustrate on this guy, but let me show you what's going on. Guys, if I split this up into 4 squares, like this, or wait a minute, does that work on this one? Hold on, let me think about that. No, shoot, I have to, okay, I'll do a different one. Let me show you a different one to illustrate what you're asking here. Okay, if I had a square, and its area was 8 meters squared, and you were like, okay, the side length's the square root of 8, and your calculator's like, that's 2 root 2, and you're like, neat. You're like, neat, okay, but what does that mean, right? Like, what's that 2 mean in front of the square root of 2? If we split this up into 4 pieces, what is the area of each of those pieces? 2, right? And each of these has a side length of the square root of 2, because that number times itself would give me 2. How many square roots of 2 long is this guy? It's 2 square roots of 2 long. And so this one would be 5 square roots of 2, because if I cut it up into like a 5 by 5, and then they would each, did I do 6 by 6? Oopsies. If you did this 5 by 5, that would be 25 squares. And if I cut up 50 kilometers squared into 25 squares, how much is each one worth, guys? 2, which means each of these side lengths is the square root of 2 long, and there are 5 of them running down the side. That's what it means, is that it's 5 square roots of 2 running down the side there. It's kind of weird, and on the cube it's even weirder. On the cube it's even weirder, but that's the idea here. Let's see here, guys. What about the 1,296? I'm assuming you guys knew to take the square root of 1,296. And that's, 36. Yay! How many of us got that one was 36 inches? Huzzah! So we don't need any exact. That is approximate and exact. It is good to go. Okay? Alrighty, guys. It is the 46th day of school. You know, the Adirondack mountain range has 46 peaks, and those who climb them are called 46ers. If you're a big climber, you could be a 46er one day. It's Slap It Annoying Coworker Day, and before you guys check, you are not coworkers. Also, I am not your coworker. So, no thank you. But if you do see Mr. Snyder walk up to me and slap me, you'll know why. You'll know why. All right. What is our first essential question? And let's go ahead and get that from Lamhi. What's our first essential question? Let's write that down, guys. How can I tell if a number is rational or irrational? All right. Famous Ben's. This one's really giving you guys a hard time. I thought I'd pick movies in your guys's wheelhouse, but I guess I didn't. This Ben, formerly married to Jennifer Garner, played Batman in Batman vs. Superman, Justice League, and also he had a short appearance in the Suicide Squad. Does anyone know which Ben that was? Do you think you know, Beatrice? Go for it. What do you think? It is Ben Affleck. Ben Affleck is the correct answer. And no, that is not the same thing. I've totally had students today be like, you mean the duck from the commercial? Like, no, that's a different thing. But yes, indeed. Ben Affleck is the correct answer. And then that is indeed park. Things that rhyme with park, that's park. Someone wrote on my last period, it's Mr. Petersen parking. And I was like, that can't be me parking because look, he's in the lines. All right. Let's see here, guys. Can I get you in 5, 4, 3, 2, 1? What a great start to the day. I really appreciate the volume, the attention. You guys are doing a really good job today. I think you do deserve a point. You guys sounded so timid about your point. You're like, oh, yes. A point for me. All right. Got a pencil? Today's topic is rational or irrational. Okay? Rational or irrational. Now, these are actually words that we have in English and we talk about all the time. When I say teach, I want you to say, okay, where have you seen the words rational and irrational before? When you're talking about things that are rational or people that are rational or irrational, where are you seeing that? Talk to each other and teach. She's on the star team. Okay. Can I get you in 5, 4, 3, 2, 1? Shh. Mo, have you ever heard the words rational or irrational before? What are they usually talking about? I would say, okay, so here's the deal. I like the direction you're going in. Good or bad, I'm like maybe. Right or wrong, I'm like closer. But what's the difference between rational versus irrational and right and wrong? Or I think I like that one. Jack, what do you think?
Is it like sane and insane?
So the sane or insane? That's a thought. Yes, absolutely. I totally get that. Credence?
Thinking it through, like
Guys can't hear Credence.
if you're being irrational, like you're getting a PhD in math, and there's something like I'm gonna go get a career and drive around in a truck. So that's irrational, and you're not thinking things through.
Yeah, so it's like you spend all this money to get a degree in one thing, and now you're just driving a truck around. It's like, although maybe that guy really knows what's going on. Do you know what I mean? I'm like, maybe that guy actually, maybe that guy's really the smartest one of them among us. Dwayne, what about you?
It's like it's like thoughtful and like just doing stuff spontaneous.
Right. Yeah. So, oh no, we got two more. We're gonna go Rex, then Annika. Rex, and then Leo.
Rational is like it makes sense, and then irrational is like it doesn't make sense.
Right. Yeah. Like rational is like it makes sense. Irrational is like it doesn't make sense. Did he steal it? You got yours, Annika. Oh no, Leo.
Like I like what Jack said.
Mm-hmm.
Like I don't really feel like irrational being insane. I feel it more just feels like not sane.
Sure, like not as really insane, but not say. I love it. Here's the thing, guys. The funny thing about this is that people sometimes take what they already think they know. I'll be right with you, Dwayne. We'll see. We have some time to come back to it. What they already know about the words rational and irrational and apply it to the numbers. Like they think rational numbers are numbers that make sense and irrational numbers are numbers that don't make sense. But it turns out, guys, that the words for rational and irrational for the numbers didn't come from the way that you use them, or the way that you use them came from the numbers. Yeah, the way people felt about rational and irrational numbers, those were applied to people who were making sense and people who weren't, right? So let's see what the heck is going on here and what we mean by rational and irrational numbers. So here we go. Got a pencil? A rational number. And the definition for a rational number came before the definition of a rational person. A rational number is a number, duh, but a number that can be written as a fraction of integers. I'll explain. A rational number is a number that can be written as a fraction of integers. We talked about integers in our very first lesson of the year, like the first math lesson that we had. And in case you don't remember, the integers are the double bar, double Z, and those are whole numbers and their opposites. So if you can have a fraction where there's a number on the numerator and there's a number on the denominator that are both integers, you've got yourself a rational number. Okay? So honestly, Jack, give me a whole number. Okay? And then let's see here. That's going to be, Calvin, give me a negative whole number. There. 4 negative 6. That's a rational number because I can write it as a fraction of integers. That's a rational number because I can write it as a fraction of integers, even if it's not reduced. If I reduced it, it would be negative 2/3. That's also a rational number. If I turned that into a decimal, which I'm actually going to do the long way, 2, 3 doesn't go into 2, 0, 3 goes into 20, I think 6 times. That would be 18. 2, oh, there you go. Yeah, because it's going to be the same thing. So that's negative 0.6 repeating. That is also a rational number. Even though it's not written as a fraction of integers, can I write it as a fraction of integers?
Yes.
Yeah, because I can write it as negative 2/3. I can write it as negative 4 over negative 6. That's a rational number. Duane. We're going to get into that a little bit later. It's not time to crack open the pie just yet. So here's another thing that happens with rational numbers. Rational numbers, when you turn them into decimals, there are 2 possible outcomes. They might end, like for example, let's see here. Like, let's go ahead and do like negative 25 over negative 8. Is that a rational number? Yeah, definitely. That's definitely a rational number because it's a fraction of integers. If I wanted to write it as a decimal, 8 going into 25, that goes in 3 times, that's 24. Doesn't go in, goes in once, or once there. That'll be 8, 2, 20, that's twice, 16, 4, 45. 3.125. One of the possibilities is that it ends, that the decimal will have an end. You'll have a 0, and you're good to go. Put your pencils down for this one, because this one stinks. Okay? 4/7. Is that a rational number? Yes. Yeah. If I wanted to write it as a decimal, let's see if it ends. 7 goes into 4, not once. 0, that goes in 5 times, I believe. 35, 5, 50, 7 times. 49, 1, 0, once. 7, 3, 0, 4. That's 28. 2, 0, 2. 14, 6, 60. Is that 9? No, 8. Only 8. 8. Uh-oh, what's 8 times 7? Is that 56? Thanks, guys. 4, 40. So, oh, wait a minute. Isn't that where I started? Yeah, 5. And then after the 5 will be 7. And then after the 7 is going to be whew, thank goodness. I finally got to a place where there wasn't a where it was the remainder that I saw before. Any fraction of integers is going to have a decimal that either ends because you get a remainder of 0, like I did over here, or eventually you're going to get a repeating remainder. Now, the reason you have to get a repeating remainder is even if this was, heaven forbid, let's see, if I got Wolfram right here? Yeah, let's get Wolfram up. Let's get Wolfram up. Because, guys, if you are dividing something by 19, can you have a remainder of 0? Could you, if you're dividing something by 17, could you eventually, or did I say 17 or 19? 19. Could you get a remainder of 0? Sure. Could you get a remainder of 12? Sure. Could you get a remainder of 4? Could you get a remainder of 25? No. Can someone tell me why you can't get a remainder of 25? Why can't you get a remainder of 25, Leo? Because 25 is bigger than 19. And so there's only a limited number of remainders, so eventually you're going to get to a place where you get the same remainder. That's why even negative 52 over 19 over here, you can ask it for more digits, but it's going to be awfully confused as to why. Because the truth is, wait, where did it go? Ah, oh no. There we go. See decimal right there? But the truth is it's a repeating decimal. It repeats after 18 steps. So yeah, you get every possible remainder except for 0. So that's why we get, that's why we have this thing happen where rational numbers always, in fact, let's write this down. Got a pencil? Because they are a fraction of integers, rational numbers always have decimal expansions, is what it's called, when you turn it into its decimal form, that terminate or end, or repeat. Rational numbers will have decimals that terminate or repeat. They can be written as a fraction of integers. I've been talking for a long time. When I say teach, I want you to say, okay, if a rational number is a number that can be written as a fraction of integer and therefore has decimal expansions that terminate or repeat, what do you think is true about irrational numbers? How do you think we can tell which ones those are? Teach!
Irrational numbers.
Perfect, tell them. Tell them. That is correct. But more importantly, because you can't write it as a fraction of integers. That is the more important part. What do you think that means irrational numbers are? Oh, of course. Yeah.
What if pi does repeat and it never repeats?
It's actually been proven that it doesn't. I don't remember, but I know that it has been. It has been. It's been proven. Can I get you guys back up here in 5, 4, 3, 2, 1? You guys did an awesome job talking to each other. I think you guys do deserve a point for that. Thank you so much, everybody. Very good. I love to see that. Very good. Let's see here. Before we get into this, Miss Hicks, on our Jeopardy, only one student all day has been able to get that without an extremely big hint. And I'm just saying, I think people in our generation, we know this guy. It's Famous Ben's. Yeah. Yeah, who is it? That is Ben Affleck. They don't know who he is. I even picked their movies. I was going to go Good Will Hunting, which is where we know him from. But anyway. P.S. I'm just going to throw it out there. Jennifer Garner's too good for him.
That is, I completely
Yeah,
agree.
absolutely, for sure. Absolutely. She's America's sweetheart.
Yeah,
Okay. All right, moving right along, guys. Come on up in 5, 4, 3, 2, 1. Leo, if rational numbers are numbers that can be written as a fraction of integers and they have decimal expansions that terminate or repeat, what do you think irrational numbers do? That's right. And can't be written as a fraction of integers. That's actually the most important part. Got a pencil? Irrational numbers are numbers that cannot be written as a fraction of integers. And so have decimal expansions that neither terminate nor repeat. Whew. Whew, kind of a lot to write. I apologize. Irrational numbers are numbers that cannot be written as a fraction of integers and so have decimal expansions that neither terminate nor repeat. I keep hearing whisperings out there about a number that you already know like this. I hear a lot of whisperings about a number that you already know like this. Does someone by raise a hand want to tell me what that number is? Let's go on Jana, please. Pi is such a number. In fact, guys, there are 3 flavors of irrational number you need to know for 8th grade. There are a lot more out there, by the way. But for now, we're only going to talk about 3. And the first one is multiples of pi. Multiples of pi are irrational. For example, pi itself is irrational. I cannot write it as a fraction of integers. Pi minus 9 is irrational. Pi divided by 2 is irrational. Negative 8 pi is irrational. If it's got a pi in it, it's irrational. Well, most multiples of pi. Leave it to 7-8 compacted students. I can't believe that it took, I think it was last year, it was the first time this ever happened. That's when I was like, multiples of pi are always irrational. And one student's like, what do you think might have been on that student's mind? What do you think, Leo? Yeah, what about 0 pi? And I'm like, okay, fine. All of them except for 0 pi. And then another kid's like, I'm like, stop it. Abby, what was it? Pi minus pi. Okay, fine. Pi minus pi, but that's it. Yeah, go for it, Tate. Pi divided. Yes, okay. Yes, it's true. Pi divided by pi. These stupid ones are indeed rational, but most of them are irrational. If the pi's divide out or you subtract them away, then they're But 5 pi minus pi is irrational because that simplifies to 4 pi. Very important. Here's another one. Oh, right, because if I have 5 pi's and I take one away, I'm left with 4 pi, and that's still irrational. Still irrational. Okay, here's the other one that's a little more familiar. It turns out all imperfect roots. Imperfect roots are irrational. Like, remember yesterday we found that we were looking for the third root of 15? Since that came out so horribly, it's irrational. Remember how we kept asking for more and more digits, and it was like, okay. But they never repeated and they never ended, and you cannot write that as a fraction of integers. Even if they're negative, like negative square roots of 12, that's not rational. Whether they're reduced or not, 2 square roots of 5, that's irrational. The 12th root of 2 is irrational. Even if it's got a rational part, like 5 minus the 5th root of 9, that's irrational. I heard a so. Yes, go ahead, Jack.
So as long as it has the square root of the root, then it's irrational.
Right, unless it reduces, right? Like, oh, sorry, excuse me, unless it, well, okay, put your pencils down for a second. For instance, guys, what's the square root of 100? 10. Yeah, what number times itself is 100? That number is 10. Can I write 10 as a fraction of integers?
Yes.
Sure, 10 over 1. So that's rational. You also have to look out for, like, if I said, what's the square root of 0.36, you might be tempted to say, oh, that's not going to be rational. But if you actually check, the square root of 0.36 is 0.6. And by the way, guys, can I write that as a fraction of integers?
Yes.
Yeah, I can. It would be 6 over 10, 3 over 5, whatever you want. What happens when it's irrational? Like if I'm like, what's the 12th root of 2? And your calculator's like barfs all over you. That's when you know it's irrational. And I'm not going to do something mean, like give you something that's like, oop, it stops right here. Ooh. Kind of a good rule of thumb is if your number is nastier than the one you started with, when you took a root, it's irrational. If your number is nicer than what you started with, it's rational. Do you know this number got a man killed? The square root of 2. The square root of 2 got a man killed. Would you like to know how? This is actually also why we call them rational and irrational numbers. A long time ago, and I'm talking like a long time ago, ancient Greece, There was a man that we're going to talk an awful lot about later, but for now I want to focus on the kid. He was a teacher. He was a mathematician. He was also a maniac. He believed that all numbers were rational. He believed every number in the world was rational, even the square root of 2. And he says, you know what? There is a fraction. There is a fraction, a over b, that we just haven't found yet, and one day we will, and all will be right with the world again. And one of his students came up to him one day and said, hey, I don't know if that's true, sir, because look, so if the square root of 2 equals a over b, do you agree that a over b can be reduced? Can a over b be a reduced fraction? So let's assume that a and b are reduced. They have no factors in common, right? If you square both sides, sir, you get 2 equals a squared over b squared, which is to say you can multiply both sides by b squared. Okay? So I get 2b squared equals a squared. And Pythagoras is like, so? And he says, well, the problem is that, well, if we come back to this a squared over b squared, I think I took this a step too far. I was doing a different proof. I apologize. I want to go back to this. Sorry. I was doing a different proof. That's a little bit above what I want to do. A squared divided by b squared equals 2. But that means that these have to have some factors in common, right? In fact, a squared needs to be equal to 2b squared. That means that they have factors in common. So, sir, I don't know that you can write that fraction. And the teacher patted his student on the head and said, oh, you silly boy. Off you go to sleep. I will find your mistakes. And he brought this problem home and could find no mistakes because there were no mistakes. And when the lesson was the next day, he's like, all right, everybody, sit down. Let's do this thing. Okay, Hippasus over there brought up this idea that the square root of 2 is not rational. So we're going to tie him to a chair and throw him in a river. And they did. And they did. And they killed him. They killed him because they couldn't prove him wrong. And it turns out he was right. Yeah. But you know what, guys? Do you think that teacher might have made a few enemies killing people over math problems? He sure did. And I'm going to have you guys know that he definitely, and by the way, this is historical fact, he definitely gets his comeuppance later on in his life. Not for killing Hippasus specifically, but for killing lots of other people because he was a lunatic. And the way that he died, I'm not kidding, involves farting. Yeah. And I will tell you more about that in February. Got a pencil? Absolutely. Okay. Guys, there's this other thing that we have to worry about. The first flavor is multiples of pi. Second flavor is imperfect roots. And then the third flavor is stupid number patterns. Like, just dumb stuff like this. 0.1234567891011. You get it? Right? Will that go on forever? Well, sure. What comes after 1, 1? 1, 2, and then? Sure. Right? You can just keep doing that. You can just keep counting up. But the thing is, guys, even though that has a pattern, it technically doesn't repeat because I can't put a bar over anything. I can never put a bar over anything and have it do the same thing forever. Okay? Also, dumb stuff like this. Negative 2.020020002 00002 ... Get it? Yeah. It's like, well, yeah, indeed, it follows a pattern. Will that go on forever? Sure. The next one's 5 zeros and a 2. Then it's 6 zeros and a 2. Then it's 7 zeros and a 2. But it'll never repeat. I can never put a bar over anything. What's that?
Why can't we just put a bar on that?
Well, because the problem is it wouldn't follow the pattern, right? If I put a bar, if I did this, then it would only be 4 zeros and a 2, and then 4 zeros and a 2, and then 4 zeros and a 2. I want it to go 5 zeros and a 2, then 6 zeros and a 2, then 7 zeros and a 2. I mean, you could.
Write down the explanation of the pattern, and then
Well, if you write down an explanation of the pattern, I would be really confused about how to turn that into a fraction of integers, though.
Oh yeah.
That's the problem, right? That's the problem. Okay, perfect. So the main idea here, guys, is that rational numbers, because the thing is, people a lot of the time, they really get hung up on this part. They're like, oh good, rational numbers are numbers that have decimals that terminate or repeat. Hooray! And then they wind up getting stuff wrong on the skill check, like this. Is 17/19 rational or irrational? Real quick, guys. 17/19, is that rational or irrational? That is rational because it is a fraction of integers. But if you actually put that in your calculator, guys, oops, that's times. 17 divided by, that's a 0. Oh, okay, man. 17 divided by 19. Does that look like it repeats?
No.
It doesn't look like it repeats to me, right? But it does. I know that it does because it is a fraction of integers, and that is most important. It is a rational number because it is a fraction of integers. And if you really want to see how long it takes to repeat, go ask good old Wolfram. Let's do it, buddy. You and me. What's 17/19? There you go. It also repeats after 18 digits. It's 0.8947368421052631557 repeating. Okay. Will you guys open up your planners to page 49, please? Page 49. Page 49. I am not 100% sure. It's going to be next week on Wednesday or Thursday. I have not decided which day yet. Okay. Page 49. Page 49, guys, is Thursday, October 23rd. Our self-assessment tonight is 7.2, rational or irrational. Rational or irrational? It's basically, here's a problem, can you round it to the nearest thousandth? Here's a thing, is it rational or irrational? Why? And that's the idea, okay? You guys are winning the scoreboard game. We're in the last 5 minutes. If you're on the star team, including Abby, Y, and Truman, who made it today, and everybody who's already on there, you guys are more than welcome to wander around to your heart's content. The rest of you guys, hang out on your assigned seats, and I'll dismiss you after these 5 minutes, okay? Go ahead, guys. Off you go. Be ready to go with the bell, and